The bypass procedure is similar to a recycle. However, instead of components within the process being sent back to the feed or another unit, a stream splits from the feed, bypasses the unit, and then mixes with the stream exiting the unit. So let's look at the picture below. Here we have a feed that's going into the system, and right here the feed splits into two streams. One of them is what's known as the bypass stream, and then the other right here goes into our process unit. And if you note, the bypass stream, as it's called, bypasses the entire unit. So here we have a stream that exits the process unit, and then here it combines with that stream, and then the final stream is a product. So we're going to look at an example of how to use this. So we're going to start with a feed stream. It's 10 kilograms per second, and it is by mass 30% A and 70% B. So this stream splits such that 20% of it forms a bypass. So here's our bypass, and 20% of 10 kilograms per second is 2 kilograms per second. And what that means is here, the stream going into the unit is 8 kilograms per second. Now this is very important because there is a split right here. All of the compositions stay the same. There's no reaction, there's no removing of any of the components. Therefore, this stream is going to be 0.3 A and 0.7 B, and this stream is going to be 0.3 A and 0.7 B. So the process unit removes enough B, so let's say we have a stream here of B such that the final product is 50% A by mass. So if this is 50% A, then it has to be 50% B as well. So let's fill in the unknowns here. So we don't know this mass flow rate, but we do know its composition because it says B is removed. Here, we don't know the mass flow rate of this, but we again know the composition. And finally here, we don't know the mass flow rate. When you have a bypass stream mixing with the stream from the process unit, the compositions cannot be the same. So this has some composition XA, and then XB is equal to 1 minus XA. And what we want to do here is we want to find all of these flow rates as well as this unknown composition. So we've labeled the system. Where do you think we should do a balance? Well, if we look at where we have the most information, it makes sense to do an overall balance. So note when we do an overall balance, we have two unknowns. So we have M1 and M2, and we have two species, A and B. Therefore, we have 0 degrees of freedom. So let's write out the appropriate equations. Coming in, we have 10 kilograms per second, and coming out, we have M1 plus M2. Now let's do an A balance, and the reason to do an A rather than a B is it means we don't have to include stream M1 because it's 100% B. So here we have 0.3 times 10 kilograms per second, and that's going to be equal to 0.5 times M2. And from those two equations, we find that our M1 is equal to 4 kilograms per second, and our M2 is therefore equal to 6 kilograms per second. So now that we have those, and let's put them in here. So this is 6 kilograms per second, and this is 4 kilograms per second. Now we're going to have to do a balance for our M3 and our XA. So let's do our balance right here around our mixing point. And again, remember, because it is a mixing point, the compositions are not the same. So we have here that M3 plus 2 kilograms per second is equal to 6 kilograms per second. Therefore, M3 is equal to 4 kilograms per second. Now we'll do an A balance there. So our 0.3, and this is coming from our bypass stream, times 2 kilograms per second. And we add that to our XA, and this is times what we just calculated, 4 kilograms per second. And this is going to have to equal 0.5 times 6 kilograms per second. And from that, we find that our XA is equal to 0.6. So now we can replace this right here, that our M3 here is 4 kilograms per second, and we know that it's 0.6A and 0.4B. And let's see if that makes sense. So if we have one stream here that's 30% A, one stream here that's 60% A, the final composition should be somewhere in between there. So you can see this is just a general material balance. However, the two important things to remember about a bypass is A, the feed stream splits to form the bypass and the stream into the unit, and they are all the same composition. And B, the bypass stream mixes with the stream from the unit, and that forms the product stream. And these streams have different compositions. As a final note, never assume that this feed stream up here splits equally into the bypass stream and the process unit stream unless you're specifically told that's the case.